Hello everyone, welcome to SCI-EASE. We have read about covalent bond and ionic bond. We know that covalent bond that is formed by sharing of the electrons and electrovalent bond that is formed by transference of the electron. Now here, in this video, I am going to take up another type of the bond, or you can say force, that is known as hydrogen bonding, which is from chapter 4th of class 11th chemistry. So the topic is hydrogen bonding. What is hydrogen bonding? First, I want to tell you this thing. First, we should know the bond energy of this bond, that how much strong this bond is. We know that there are van der Waals forces, bond energy of these forces, van der Waals forces, dipole-dipole or dipole-ion forces, that is less than 8 kilojoule per mole. Okay? And there are covalent and ionic bonds which have bond energy greater than 200 kilojoules per mole, greater or equal to. And now I am telling you about this hydrogen bond. So the bond energy of hydrogen bond that is greater than van der Waals forces and less than covalent bonds or ionic bonds, it is in between 8 kilojoules to 42 kilojoules per mole. So, this thing that is clear, that bond energy of van der Waals forces that is very less than 8 kilojoule per mole. This means that they are the weak forces. Bond energy of covalent and the ionic bond is greater or equal to 200 kilojoules per mole. So it is a strong bond. And the bond energy of the hydrogen bond that is in between van der Waals and the covalent or ionic bonds. So it is 8 to 42 kilojoules per mole. So its bond strength, that is, this means that there is one question in the exercise, that which one of the two is stronger, van der Waals or hydrogen bond? So here you will say it is the hydrogen bond which is stronger than the van der Waals forces. Now I will tell you something about the hydrogen bond. In hydrogen bond, presence of hydrogen atom is must. Okay? Suppose there is atom A and H, where there is bond formation. Now this is not the hydrogen bond. This atom A may be fluorine, okay, oxygen or nitrogen. That is the electronegative atom. A is some electronegative atom like fluorine, oxygen or nitrogen. When you will study organic chemistry, then there you will see that in that case electronegative atom is sometimes carbon or chlorine also. This is in organic chemistry. And I want to tell you that in case of the organic chemistry, most of the reasoning questions, they depend upon the hydrogen bonding. When there is any question related to the solubility of the compounds, so you will say that the compound in which there is hydrogen bonding, that is more soluble. In the same way, when there is question related to boiling point, then you will say that the boiling point of that compound, that is higher where there is hydrogen bonding. So in case of organic chemistry as well as in inorganic chemistry, you will find so many questions based on the hydrogen bonding. That is why I want that you should understand what hydrogen bonding is. Now, I have told you that this is the bond AH and this is a covalent bond. Okay? And A may be fluorine, oxygen or nitrogen, that is the electronegative element. When there is bond formation between the two, the shared pair of the electron that will be shifted more towards a more electronegative atom. So, here there will be positive charge on hydrogen and negative charge on partial positive and partial negative charge on A. Okay? On H there will be partial positive charge and on A that is partial negative charge. When some other element like B, which is again, it may be fluorine, oxygen or nitrogen, and in organic chemistry it may be chlorine. Okay? When it comes closer to this H with its lone pair, what will be the result? This lone pair that will be shared by this hydrogen and there is bond formation between hydrogen and this B. This means that there is some bond, and what is that bond known as? That bond is known as hydrogen bond. Once again, I will tell you that there is one molecule AH. Okay? A is electronegative element like fluorine, oxygen or nitrogen. They will form a bond, covalent bond, and in that case, the shared pair of the electron between A and H, that will be shifted more towards A due to its higher electronegativity, and as a result of it, there is partial positive charge on H and partial negative charge on A. When some other electronegative element like B, it comes closer to it, what will be the result? With its lone pair, this lone pair that will be shared by this hydrogen and there is formation of the hydrogen bond between H and B, which we depict by dotted line, and this bond formation is there. So, what are the characteristics? What should be the characteristics of this B that I want to tell you? First thing is that B should be electronegative element. Electronegative element. Like this I will write. Second, B should have lone pair of electron. Okay? And third thing, that is that B should be small. So there should be three characteristics of this B, and as a result of it, hydrogen bond that will be formed. Okay? So this is the hydrogen bond. I will tell you by taking some examples, the things will become more clear to you. Okay? Now, I will tell you now that how this bond that is formed between the molecules. I will take one example. First is HF, H and F. Okay, I will write it like this. F, H. So, this is the covalent bond between hydrogen and fluorine. Shared pair of electron that will shift more towards the fluorine. Okay, and as a result of it, partial negative charge on the fluorine and partial positive on hydrogen. So, another molecule of HF that will come closer to it with its lone pair, and this will result in the formation of hydrogen bond. This will result in the formation of the hydrogen bond. So, you will see that HF molecule, this bond is covalent. This should be clear to all of you. The bond between the two molecules of HF, that is the hydrogen bond. So, many molecules of this HF, they can combine together and they will result in the formation of hydrogen bond. Clear? So, this is AHB. AHB. No, it is AHB. This is AHB. Okay, so the thing should be clear to all of you that bond energy of hydrogen bonding is in between the van der Waal and the covalent and ionic bonds. Second thing, how this bond that is formed, that I have told you that there is involvement of hydrogen and electronegative elements. And the electronegative elements are fluorine, oxygen and nitrogen. The sequence is like this. Fluorine is most electronegative. Okay? And oxygen is lesser than fluorine and nitrogen is lesser than oxygen. Now, tell me that if it is the bond length of this bond HF, that is X, and the bond length of this HF bond is Y, which one will be longer? Which one will be longer? The bond length between HF, that is Y, it will be longer. Why? Because here this bond is stronger. This means that the molecules, that this HF bond, that will be smaller. The atoms, they will be closer to each other. But in this case, the molecules, they are far apart, and that is why this bond length, that will be longer. This is a strong bond. More stronger the bond, lesser will be the bond length. This we have read already. Okay. I told you about the bond parameters. There I told you that more stronger the bond, lesser will be the bond length. So this question can be asked that which one of the two that will be stronger. Now I want to tell you one exception here. The molecule of HF, okay, HF2 negative. HF2 negative. This is an exception. Now this is FH. Covalent bond is there. There is partial positive charge. There is partial negative charge because this is electronegative element, and the shared pair of electron that will shift more towards fluorine than towards hydrogen. Okay. Then an F negative that will approach near to it. Okay. And the bond which is formed here, the bond which is formed here, that will be hydrogen bond. But here, I will tell you this. In this molecule, this HF bond, which is hydrogen bond, its bond energy is also 200 kilojoule per mole. So the bond, and in this case, you know that this is already 200 kilojoule per mole. Okay, so you can see here that there is exception, that is HF2 negative molecule, where the hydrogen bond has the same strength as the covalent bond. So exceptions, they are there in chemistry. In every subject there are exceptions, so you must learn this thing, because sometimes the question is asked that in case of HF2, how this hydrogen bond, it has the same bond energy as that of the covalent bond. Okay. Now I will come to the types of the hydrogen bond. So there are two types of the hydrogen bond. Types of hydrogen bond. Hydrogen bonding. One is intermolecular hydrogen bonding, and second one is intramolecular hydrogen bonding. What do you mean by intermolecular hydrogen bonding? Intermolecular means different molecules. Like there is inter-house competition, that there are 4 houses in your school, okay, and when there is match between all these 4 houses between, okay, then this is known as inter-house competition, inter-house basketball match, okay. But when there is any competition like poem recitation competition within the house, then it is known as intra-house competition. So the terms intermolecular hydrogen bonding and intramolecular hydrogen bonding, that must be clear to all of you. So I have told you one example of HF, that is the intermolecular hydrogen bonding. Okay, here the 2 molecules of HF or many molecules of HF, they are joined together by hydrogen bonding. Okay, there are other examples also. You can take the case of water, HOH, and here HOH, AHB. So there is hydrogen bonding in between. In the same way, there is another molecule of water. They all will be connected by hydrogen bonding. So this is the example of intermolecular hydrogen bonding, when the hydrogen bonding that is in between the different molecules of the different molecules which contains the electronegative element and the hydrogen atom. Okay, so I will tell you more example. You can take the example of ammonia also. And now the third example of intermolecular hydrogen bonding is ammonia. Okay, N, H, and H. This is electronegative element. There will be shared pair that will be shifted towards this. This will be AHB, another molecule. that will come. Okay. Then third molecule. So the bond between H and N, that is the hydrogen bond. Hydrogen bond that is depicted by the dotted line. Okay? It is depicted by dotted line. So this is the intermolecular hydrogen bonding, that is between the different molecules the bond is formed. One question is there, I will ask you this question, that the hydrogen bonding between HF molecule, okay, second water, H, O, H, H, O, H, and third is ammonia. Which one is stronger? Which one is stronger? This question can be asked, that which one, the bond between these molecules, which is, we will say that it is the intermolecular hydrogen bonding, which one is stronger? So HF will be stronger. In HF, the intermolecular hydrogen bonding, that will be stronger than water, than ammonia. Why this sequence? Why this sequence? Because the bond energy, or you can say bond strength, that is directly proportional to the electronegativity of A. Here A is fluorine, here A is oxygen, and here A is nitrogen. So the bond, this electronegativity of fluorine is greater than oxygen, is greater than nitrogen, that I have told you. So the bond strength, that is directly proportional to the electronegativity of A. Okay? And there is again one relationship, that the bond strength, that is inversely proportional to electronegativity of B. Electronegativity of B. Okay? Suppose there is some question, OH and OHO, and here it is OHN. Okay? And there is third option, NHO and NHN. Which one out of these four, which one will have the strongest, you can say, hydrogen bonding? So I have told you that bond strength, that is directly proportional to electronegativity of A. This means electronegativity of oxygen, that is more. So these two options, they will be ruled out. Okay? Here the electronegativity of nitrogen, that is less. Then out of these two, which one will have the stronger? Which will have the stronger hydrogen bond? Okay? It will be option 2. Why? Because bond strength is inversely proportional to the electronegativity of B. So electronegativity of nitrogen is less than oxygen. So this will have the strong hydrogen bond. I think side by side, I am telling you the reasoning questions also, they can be asked. I have told you that in organic solubility and the questions relating to the boiling point, whenever that is asked, you will say in the compound in which there is hydrogen bond, that will be more soluble. The compound which will have the hydrogen bond, that has the high boiling point. Here I have told you so many questions side by side. Now I will take up the second type of the hydrogen bonding, that is the intramolecular hydrogen bonding. Clear? Intra means within the molecule. There is one example given in your textbook. I will take up that. That is ortho nitrophenol. When you will study this organic, I will tell you that what is the organic compounds and what are phenols, what are aldehydes, what are ketones, and so many functional groups I will tell you. But here I will take up this example. Phenol has, first I will tell you that what are the ortho, meta and para position in benzene. This is the structure of benzene. Suppose this here there is some functional group attached. So this is the ortho position. This is again the ortho position. These are meta and this is para position. Okay. So I will draw the structure of ortho-nitrophenol and I will tell you how this intramolecular hydrogen bonding is there. So I have taken this phenol. Okay, suppose this is phenol. And here there is nitro group attached at which position? Ortho position. So it is NO double bond O. So the force here the bond between hydrogen of phenolic group and oxygen of this nitro group which is formed, that is the intramolecular hydrogen bonding. Okay. So sometimes there is question that which one of the two will have the higher boiling point. This is, I am drawing the structure of para-nitrophenol and here is another molecule of para. So in case of this para-nitrophenol, this intramolecular hydrogen bonding, that is not possible because the group is far away. Both the groups, they are far away from each other. So when another molecule of this para-nitrophenol is there, so here the bond that is formed, that is hydrogen bond, and here there is NO2 group, suppose. So this is the example of the intermolecular hydrogen bond. Here the two molecules of para-nitrophenol that is taken and the bond that is formed between the two molecules. And here the bond that is formed within the molecule, that is the intramolecular hydrogen bonding. Sometimes there is question that which one of the two will have the higher boiling point. So here this will have, para-nitrophenol will have the higher boiling point. Why? Because here the hydrogen bond between the two molecules will break. That will require more energy. And here the hydrogen bonding within the molecule, that is to be broken down. So the boiling point of this is para-nitrophenol, that is higher than the ortho-nitrophenol. So side by side, I am telling you the reasoning questions also. So I have told you what is hydrogen bond. Okay, there is involvement of hydrogen and electronegative elements. And what is the bond strength of the hydrogen bond, that I have told you, bond energy, that is 8 to 42 kilojoules per mole. Then I have told you about the types of the hydrogen bonding, that is intramolecular hydrogen bonding and intermolecular hydrogen bonding. In case of intermolecular hydrogen bonding, we have discussed the bonding between HF molecules, between water molecules, and between the ammonia molecules, and in which molecule the bond is more stronger, that is HF bond. Between the molecules of HF, hydrogen bond that is more stronger than water. It will be more stronger than ammonia. And then I have told you about the intramolecular hydrogen bonding, that what do you mean by intramolecular. I have taken the example of ortho-nitrophenol, and also I have compared ortho-nitrophenol with the para-nitrophenol, that in case of the para-nitrophenol, intramolecular hydrogen bonding is not possible. So with this, my topic, hydrogen bonding, that is complete. I think the things, they are clear to all of you. I will come in the next video. I will take up another concept of class 11th chemistry. Till then, thank you very much.